Hello students, how are you? Myself Prashant Kumar Srivastava. Today I will teach about fundamental forces in nature. There are four fundamental forces in nature: strong nuclear force, weak nuclear force, electromagnetic force, and the gravitational force. The range of the strong nuclear force is 10 to the power minus 15 meter or 1 Fermi, and the particle which is responsible for the strong nuclear force is gluon and the pi nucleons. Electromagnetic force has the range infinite, and the responsible particle is photons whose mass is 0 and spin is equal to 1. Weak nuclear force has the range 10 to the power minus 18 meter, and responsible particles for the weak nuclear force are the W plus or W minus boson, and its energy is greater than 80 giga electron volt. And the gravitational force has the range infinite, and the responsible particle for the gravity is gravitons. Okay, this is about the fundamental forces in nature. And the electromagnetic force is very strong, magnetic force is very strong, and both are the part of electromagnetic force. Electromagnetic force are produced when charge is in rest, and magnetic force are produced when charge is in motion in presence of magnetic field. The strong force which can hold a nucleus together against the enormous forces of repulsion of the proton is strong indeed. However, it is not an universe square force like the electromagnetic force, and it has a very short range. Strong nuclear force exists between the neutron and the proton, between the two protons, or between the two neutrons inside the nucleus, and its range is 10 to the power minus 15 meter. Gluon and pi meson particles are responsible for the strong nuclear force. First time this is explained by the Robert Ikawa, who is the Japanese scientist, who proved that strong nuclear force is due to the presence of pi meson particles, and he completely explained the Rutherford model about the stability of nucleus. Electromagnetic force, one of the four fundamental forces. Electromagnetic force manifests itself through the force between two charges, and the magnetic force, both of which are summarized in the Lorentz force laws. Fundamentally, both magnetic and electric forces are manifestation of an exchange force involving the exchange of photons. The quantum approach to the electromagnetic force is called quantum electrodynamics, or QED. The electromagnetic force is a force of infinite range which obeys the inverse square law and is of the same form as the gravity force. Weak nuclear force, one of the four fundamental forces. The weak nuclear interaction involves the exchange of the intermediate vector bosons W and the Z. Since the mass of this particle is on the order of 80 giga electron volt, the uncertainty principle dictates a range of around 10 to the power 18 meter, which is about 0.1% of the diameter of a proton. The weak interaction changes one flavor of a quark into another. For example, in neutron decay depicted by the Feynman diagram at left above, one down quark is changed to an up quark. Okay. Weak nuclear force is also due to the beta decay. In case of beta decay, there is a electron and neutrino particles are emitted, and there is weak interaction between electron and the neutrino particle, and this weak interaction known as the weak nuclear force. Gravitational force. Gravitational force is the force of mutual attraction between two bodies by the virtue of their masses related by F is equal to G m1 m2 upon r square. It is a universal attractive force. It obeys inverse square law. It is the weakest force in nature. It is conservative, central and long range force. It is caused due to the exchange of particles called gravitons. Strong force bind the nucleus, electromagnetic force bind the atoms, weak force in radioactive decay, and gravitational force bind the solar system. Okay, and this is the concept of the fundamental forces in nature. Okay, thank you so much. Myself Prashant Kumar Srivastava. Please like, subscribe and share my YouTube channel. Thank you so much.